All right. So yesterday we talked about what a reference angle was. Okay. And really calculating reference angles weren't a problem because they were all like our unit circle values. Okay. We're gonna have to think a little bit harder when we don't have a unit circle value. So let's just go through different scenarios. If I had an angle in the first quadrant, how would we calculate the reference angle?
Oh yeah, you don't know.
In the first quadrant, you're going to have an acute angle, right? A reference angle is the acute angle back to the x-axis. In the first quadrant, a reference angle is itself. Probably not going to ask you for a reference angle of a quadrant 1 angle, but we talked about it. Okay? In the second quadrant, we're talking about the angle to the x-axis. We'd be talking about this guy right here. How would we calculate that in radians?
Well, it's like pi minus whatever your reference is.
Pi minus whatever our angle is.
Yeah.
Okay, good. We can visually see that these two would add up to be 180 degrees, or pi. So we would need to subtract out that red angle to see what was left over. Okay. If we were in the third quadrant, okay, remember we're always going back to the x-axis so that we have an acute angle. So there would be our reference angle. In radians, how would we calculate this one? What else?
Pi plus the reference
Okay, so if we don't know what the reference angle is,
the original angle minus pi.
okay, so our original angle is bigger, right? And then if we subtract out pi, we're left with this reference angle that would be left over. Okay, that's the only time that you're going to do the original angle first because we're more than pi. Okay, and then in the fourth quadrant, this guy right here would be our reference angle, okay? What do the red and blue add up to be? Okay, but in radians? Okay, so to find our reference angle, we would take 2 pi minus our angle, and we're left with that chunk that would be our reference angle. Okay. So I'm going to give you, we're going to do 3 examples, but I'm going to have you do 2 of them first at your table. Okay, and then we'll do the third one together. I want you to find me the reference angles of 325 and 7 pi over 5. My suggestion to you would be to graph it first so you can see which quadrant it is in, and then you can visually see the measurement that you need to use to help you find it, okay? I don't want it quiet in here. I want you talking to each other, working together, okay?
What are you doing?
I feel like I think that 7 pi over 5 we still have it. We're gonna keep going.
Yeah.
It's scary news.
Okay, I would rather live in radians.
Really?
Well, I was thinking about the fractions, so this is like 1/2 pi, 1 pi, 3 halves pi. Well, 7 is over 1, but it's less than 3 halves, so it's somewhat of this twice. Sydney, which quadrant is 325 degrees in?
Quadrant 4.
Quadrant 4. So here is 325 degrees, okay? And if we want our reference angle, okay, Addie M, how did you calculate the reference angle? Which is? Do you notice how I'm writing the degree symbol?
Yes.
Some of you did not do that on your quiz, and I was kind and I didn't take off points. I will start taking off points for that because there is a difference between degrees and radians, and the only way to notate that is with that degree symbol. Okay? Do we agree with Addie?
Yes.
Okay. An overwhelming yes is what I heard.
You did great. Yeah.
As I walked around, I saw you guys had 35 degrees. Okay, I know you agree. Okay, so our activity didn't really work, huh? I don't really have a lot of energy. Okay. Jessica, which quadrant is 7 pi over 5 in? The third. Okay, I had a question like, how do we know? How do we know? All right, we know that like right here is 1 pi and right here is 3 halves pi. If we think about the fraction 7/5, we know that it's bigger than 1, but not quite 1 1/2. So we would throw it in that third quadrant. Okay? So to calculate our reference angle, Austin, how'd you do it?
I subtracted 5 pi over 5 from 7 pi over 5.
Okay, so you took 7 pi over 5, and he went ahead and changed pi to 5 pi over 5, so the calculation would be easier. So Austin got 2 pi over 5. How do you feel about that?
Good.
2.3.
Oh, okay, I get it now. It's in radians.
Oh, it's in radians. Okay. 2.3 would be where?
And then the second.
Who said that?
Second.
Why?
Well, because like there's 3.14 radians and 180 degrees because that's pi. So, you know, if you do like 2/3 of that, then you're going to be in the second quadrant.
Okay. So Max was not tricked. Okay. Some of us were thinking, oh, this is like 1 time around and then a little bit more. It's not. There's not a pi with it. So we need to think about what our radians are in decimal form. Pi is approximately 3.14. So 2.3 is going to be somewhere in here. Okay. So to find our reference angle, we would have to take pi minus 2.3. Well, if pi is approximately 3.14, 3.14 minus 2.3 would be
0.84.
All right. Ready for the fun stuff? Okay, to me this isn't really that exciting, right? Reference angles. Okay, let's get some real trig going on. All right. So as a reminder, all students take calculus refers to the major trig function that is positive. Okay, they're all positive in the first, sine in the second, tangent in the third, cosine in the fourth. Okay, when you think about those three trig functions, their reciprocals would also have the same positive or negative. Okay, I don't want to say sine as S-I-G-N because then it sounds like sine. Okay, so I want you to keep that in mind. If you need to make a little note in the margin of your work to remind yourself about this, I have no problem with that. Okay, because we're going to get to problems like this. Okay, evaluate the 6 trig functions when our angle goes through the coordinate -3, -2. Okay, now why is the answer not sine of theta equals -2 and cosine of theta equals -3? Why is that not the answer? Okay, the unit circle has a radius of 1. This does not have a radius of 1. Okay? You were right in your answer. Okay? The unit circle has a radius of 1. The coordinate -3, -2, it's going to take us longer than 1 unit to travel on that hypotenuse. Okay? So what we get to do, if we have angles that are not special unit circle values, we get to use our knowledge of right triangles. Okay? So does everybody have the coordinate plotted -3, -2? If you don't, draw your xy axis and plot the coordinate -3, -2. Okay? We've been talking about reference angles. We are going to use reference triangles to come up with the trig functions for this. Okay? So there's our reference angle, and I'm going to go ahead and make a reference triangle. Now, we traveled an x distance of 3 and a y distance of 2. So we know that the sides of that triangle are 3 and 2. Okay? Which means we can find the hypotenuse by doing what?
X squared, b squared.
Okay, the Pythagorean theorem. So if we do the Pythagorean theorem, 3 squared plus 2 squared, our hypotenuse has a length of square root of 13. Okay. Now, since we are, I'm going to tell you like 2 different ways you can go about doing this. Okay? Way number 1. I have my legitimate triangle up there. It's my reference triangle. Since we're in the 3rd quadrant, I know that the sine and cosine will be negative and the tangent will be positive. Now I can look at my reference triangle and I know that the sine ratio is opposite over hypotenuse. And then I'll rationalize. Okay. Our cosine ratio is adjacent over hypotenuse. And then I would rationalize. And then our tangent is opposite over adjacent. All from that reference angle. We got those ratios. Okay? And then for the other 6, we can take the reciprocals. So first of all, I got all those ratios from the right triangle. Before I did that, I threw in where the negatives and positives should be. If you'd rather, come over here and label the 3 and 2 as negative to match your coordinate, that is fine also. Now, we all know that we can't have a -3 side length, and we can't have a -2 side length. We know that that's not a thing. And you are not saying that the side has a length of -3 or -2. You're just notating yourself that we went left and we went down. And if it helps you to remember where to put the negative signs, I am fine with you labeling your reference triangle this way. Okay? I would hate for you to create the reference triangle and forget to put in your negatives and positives for your ratios. So if this helps you remember, you can do it this way. And I have no problem with it. Okay? What questions do you have from this example? Okay. So let's do another one. Let -3, 4 be a point on the terminal sine of theta. What should you be doing? You should be drawing a picture with the coordinate -3, 4. Okay, so here's what the angle looks like. Excuse me. We want the sine, cosine, and tangent ratios. However, okay, we're not on the unit circle, and we are past 90 degrees, so we can't really make a legitimate triangle. But what we could do is we could make a reference triangle. Okay, make sure you are always going back to the x-axis like we talked about with our reference angles. Okay, and since we have this from a coordinate, we know that we moved left 3 and up 4. How many of you think you would like to label the 3 as -3 on your triangle? Okay. Oh, this is nice, isn't it? What's our hypotenuse? 5. Wait for it. There it is. Okay, so one of two things here. You can say, all right, I'm in the second quadrant, so I know that sine is positive and that's it. Or you can label the 3 as a -3, like some of you have already chosen to do, and then find your ratios that way. So our sine ratio, opposite of the reference angle over hypotenuse. Our cosine, adjacent over hypotenuse. And our tangent, opposite over adjacent. It is important that you draw the picture and you draw your reference triangle back to the x-axis. Some of you are going to get a little bit excited and not want to draw this, you need the picture. Okay, don't try to do this from memory. Okay. Same thing with a problem like this. Go ahead and write down the information and kind of digest it for a little bit. I'm going to give you about 20 seconds to talk with your pod about which quadrant this angle would live in. Ready, go. Okay, I think that was a little longer than 20 seconds, but that's okay. Kaya, which quadrant is this in?
The fourth.
And how did you come up with that?
Since cosine is positive, it had to be 1 or 4, and then since tangent is negative, it's 4.
Okay, so cosine is positive in the first and the fourth quadrant, but our tangent ratio is negative, so that eliminates quadrant 1. It has to be in quadrant 4. Okay, so we will draw our angle in quadrant 4. And then our reference triangle can then be drawn back to the x-axis. And we know 2 of the sides, don't we? Okay. Our tangent ratio is 5/4. So we know that opposite is 5 and adjacent is 4. Now, those of you that like to label the negative on your triangle, is the 4 negative or the 5 negative? The 5 would be negative because we traveled down 5. Okay. So now what we can do is we can think about our hypotenuse. So if we have adjacent is 4 and opposite is 5, with the Pythagorean theorem, what would our hypotenuse be? Square root of what?
41.
Square root of 41. Do you agree with Pod 5's calculations?
Yep.
25 plus 16 is indeed 41. Okay, so those of you who want to label on your triangle the negative 5, go for it. Okay, so we're in the fourth quadrant. We know sine and tangent are negative, cosine's positive. So now we can identify our sine ratio as opposite over hypotenuse. And cosine adjacent over hypotenuse. Okay, and then of course we'll have to rationalize those fractions. Okay, you don't want 4 over radical 41. Okay, they've already given us tangent, and so then if we want the cosecant ratio, we would take the reciprocal of sine. If we want the secant ratio, we would take the reciprocal of cosine. And then the cotangent ratio, we would take the reciprocal of tangent. Okay? Now, notice when I'm doing the cosecant and secant ratio, I am not flipping this fraction and then rationalizing again. Okay? If you had to rationalize your fraction, When you go to take the reciprocal, please think of it in its unrationalized form, so you just have to do a simple flip of the numerator and denominator. Okay. All right. Nothing too life-changing. These are things that you kind of did last year in Algebra 2, or definitely did last year in Algebra 3. Okay, pack everything up. You have a book, homework assignment. See to it that gets done for me.